Awesome. She was a Trekkie. So being able to envision yourself in the shoes of an astronaut is the kind of thing that motivates the public to get on board with the space program. Without being able to envision yourself in those shoes, you wouldn't aspire to be better at mathematics, be better at physics, be better at astrophysics, all of those things. And so human exploration increases public support for the space program, which then translates to all other kinds of benefits. Once you have more public support for the space program, we get more satellites up there, we get more funding for research, we get more space stations, all of those things. And it translates into other benefits. And so this is kind of the flagship mentality, that we need humans up there so that we can have heroes, so that the public can get behind it. Absent that, it's all kind of a robotic, weird thing that NASA handles that we don't know very much about. The next reason that humans are good is that they can complete complex tasks and deal with in-flight mistakes. So an entire program, if a single robotic arm were to go bad, the entire mission that cost billions and billions of dollars would fall by the wayside. But getting humans up there, they can fix components of the spacecraft that break, they can do innovative missions, and they can incorporate new technological innovations that have taken place back on Earth that have been communicated to them that couldn't have happened if they had just left with all the technology that they had. They can redesign different thruster systems, things like that. Another argument, and this is where we start to get a little bit critical, is that we shouldn't let technology experience the universe for us. We shouldn't just simply be plugged into robots and have like a little an avatar of our space exploration that experiences space for us, and we just have virtual reality simulators and we can actually go to space. A lot of people say that that's not the way to do it. That we need to put ourselves on the line and that we need to actually experience what it looks like from space. There's some other reasons for this in a moment, but let me read this card to you. This is from Silver, 2002. Humans have deep psychological needs that I label the spirit of adventure and the spirit of colonization. These needs are increasingly unable to be satisfied within the modern world. The opportunities for adventure have been reduced to those who can manufacture artificially, and the opportunities for colonization to experience the intellectual profundity of the frontier have become non-existent. The only means to restore these experiences to the human or transhuman condition is to pursue space, not just robotically, but at a personal level, as explorers and colonists. The alternative is to grow ever more inward, satisfying our psychological needs through drugs or virtual reality simulations or other high-tech means not yet conceived. This is the same concept as plugging an electrical stimulant directly into the pleasure center of the brain. That is the path to degeneracy and ultimately extinction. Extinction. Also, humans in space foster a better climate of international cooperation. The International Space Station is the key example. The Russian space program for a long time was considered the most significant and most developed space program, and the ability of our astronauts to convene with the Russian astronauts was hailed as a symbol of international cooperation and victory. Without humans there, it would be our robots interacting with their robots, nothing that was very profound. But the symbolic value of shaking hands in outer space is something that shouldn't be underestimated. It really lends a culture of cooperation. I'm not sure if you guys have heard this joke about how the United States spent millions and millions of dollars trying to figure out how we could write in space, trying to develop a space pen that you could write in space with that would write in zero gravity, and the Russians just used pencils. I don't know, I thought that was a good anecdote. Was there a question back there? No. Okay. So the next reason that humans need to be in space is this phenomenon called the overview effect. The overview effect was posited very early on by an astrophysicist named Boyle. He said that once we get a picture of the Earth, the implications of seeing the Earth for the first time in a photograph will be as profound and transformative as any idea in history. And in many respects that came true. The idea, and I think Tracy has a really good characterization of this, is that once we get up into space and look back on the Earth and see how fragile and beautiful the Earth is, we'll all sit around and sing Kumbaya and get along together and love each other. But the cards for this are absolutely phenomenal that insist on saying the overview effect. That once we get out into space and look back on the Earth, we realize that we're all one whole, we're all one species. And then once we realize, and there's several components to this, we'll talk about these a little later, but let me give you an example of a card. This is from Crouch 2001. This is a little bit different actually, that's not the overview effect. I'll read an overview effect card later. But here's an example of when I was doing critical research for this app, for the Let's Get Out into Space primitive, I'm thinking about what are the values of human meaning, what is the ultimate value to human life. I did find something that said we could, I was asking the question, how long could we extend human life for? What's a reasonable time for the human species to survive? How would we evaluate that or whatever? And I found one card that humans cannot survive for more than 100 trillion years. Or 100 trillion years. And that colonizing Mars would enable us to live for that long. And so we would be able to fill out the maximum life of our species. That's pretty good. But here's another example of a card in which the ultimate value of human life that comes through space exploration is brought into perspective. Professor of astrobiology. The development of space flight and nuclear technology seems to verify the argument that there is an upward spiral of intellectual evolution on Earth. In order to avoid extinction from minor cosmic catastrophes, humankind can use actualized scientific knowledge to protect its world by sending rockets to intercept coming comets or asteroids. By the way, there's a comet that's entering into the Earth's orbit in about 14 hours, I think. It's a small one. However, animal and plant populations must eventually be dispersed to other planets or space habitats that have been terraformed to avoid major cosmic catastrophes that will cause extinction. Life tenure on this planet is not secure. Dispersion of matter increases the chances that life will develop in different places in the universe. Dispersion of life on a planet or in the universe is preferable, so life will not easily be obliterated by local or cosmic catastrophe. Thus, forms of life will have a greater chance to survive a catastrophe and produce offspring. Consequently, it might seem to follow that if there is meaning for human life, as with life in general, it might be found in successful adaptation, dispersion, and reproduction. Very conclusive card. There are very few that come out there and say that in the context of space exploration, that the meaning of human life is the very task to venture forward, to boldly go, etc. Yeah?
Can you scroll up a little bit?
Again, all these cards will be in our file. Are you good? Okay. So that's the gist of how human exploration, putting humans on the rockets, is important. Regarding the moon, it takes 3 days to get there. It's important for research on the earliest beginnings of the solar system because the moon doesn't have an atmosphere, it doesn't have wind. And so the surface of the moon is significantly unchanged, except for asteroid collisions. And it has a very clear layering system. And if you look on Google Moon, you can actually see which meteors hit first. Because if one hits first, you can see it leaves an impact. The one that hits over it will layer that space dust over that asteroid. So the entire surface of the moon is like a giant genealogy, a family tree of asteroids and meteorites that have hit the moon. And so it has a lot of history and enables us to understand more about the universe, etc. But once again, exploring this genealogy of the moon and the constitution of asteroids and the composition of space dust and things like that only has exploratory benefits, such as we can discover new things about the universe. But these are kind of nebulous and not directly helpful, and so don't make very good debate impacts. It is true, because it only takes 3 days to get to the moon, that we can get resources from the moon. Helium-3 is the best example. Have any of you debated this affirmative yet? In your practice debates or mini debates? Right. So what are the advantages to helium-3? Yeah. Fusion. What does that mean? How? Right. Well, one of the things that helium-3 is used for more than anything else is that we can reach very, very, very cold temperatures with helium-3, very close to absolute zero. And so that enables a type of cryogenic freezing and also the slowing down of nuclear reactions such that we can actually observe and control them in a way that we couldn't with just the isotopes of helium that are here on Earth. And we can actually get them back from the moon. Now, one of the dilemmas of just saying resources is you have to establish an infrastructure for it, and you have to actually bring them back. So it won't be an instantaneous sort of immediate advantage that you can get from moon mining. And again, any sort of economic disruption or political destabilization or something like that that happens on the Earth will turn your case. It will short-circuit your ability to solve because it undermines the infrastructure for the transportation of those resources. Which is why some of the advantages for the moon tend to stem from things like the Moon Treaty, where we agree on resource deals and things like that, of how we can't own the property of the moon. The moon is humanity's property. And so any sort of mission that we send to the moon already has protocols built into it for what we do when we get to resources and when we make discoveries. And so in the very gesture of funding a program such as that, the clarification of what we're going to do when we get there, what we get with the property, etc., that clarification will have international ramifications. There will be international agreements that we fall under or that we break. And you can do that both ways. You can do the moon in such a way that you conform with international standards, you set a new precedent, or you can do one such that you break with international standards and you can claim that the international framework for the right to the moon is flawed. We need a new system. So you can go both ways as far as moon mining is concerned. Some people feel that the moon should be considered a stepping stone or a waypoint to future missions. For example, a lot of those same people that advocated Hubble and the emergence of this new telescope say that we should put a radio telescope or a visual telescope on the moon, because then we can have a vast spectrum of new investigations and things like that. It can also be a stepping stone to future colonies for both Venus and Mars, because the moon has a lower gravitational pull, and so once we set up kind of this waypoint or home base on the moon, we can very easily launch rockets or space flight to other planets and further into space as well. And it provides for early warning for asteroids. And asteroids, as you know, is the sweetest app on the topic. Can't be sarcastic. Also, having a lunar base is less maintenance than the space station, the International Space Station. And improving the survivability of our space stations increases the ability of us to do experiments and to answer questions about human reproduction. To the best of our knowledge, there have been no humans that have had sex in space, and there's been no pregnant. There was a married couple that was in space, though, but I'm pretty sure that NASA didn't want any hanky-panky going on. But if we're going to colonize Mars, or if we're going to have a life in the solar system, we need to understand how the lack of gravity or different atmospheres will influence the human ability to reproduce. For example, the formation of the umbilical cord largely depends on a gravity environment, right? So we can't reproduce in space. We have to simulate gravity in order for human colonization or anything like that to take place. Those experiments can only happen on the moon for long periods of time. And we can also experiment with new technologies such as energy that we couldn't do on the Earth because they're too dangerous. Certain types of nuclear experimentation I would rather not have happen in my backyard. Okay, this leads us to Mars. Well, are there any questions about the moon so far? Yes?
I was going to ask you to get some water.
What?
Get some water.
Can you get some water?
Yeah.
Yeah.
Okay. Sorry.
Yeah, you don't have to ask me. You can go to the bathroom to get water. Okay, Mars. Mars is the fourth planet. The implication of the fact that it's a fourth planet is that it has a bigger orbit and it has less sunlight. Most people think that because Mars is the red planet, that it's hotter than the Earth. That is not true. It is colder than the Earth. But it's not that much colder than the Earth. Some of the coldest temperatures on the Earth, which I think is like 89 degrees Celsius is the coldest temperature recorded on the Earth, in Antarctica, the coldest temperature recorded on Earth is actually colder than some of the warmer temperatures that we experience on Mars. This is not the case on Venus, where the temperature is 1,000 degrees. And the atmospheric pressure is something like 200 times that that's on Earth. And so it would be like being at the very bottom of the ocean. We sent a few landers to Venus, and I'll talk about this down below, actually. Mars is undoubtedly the most habitable planet in the solar system. This is because there's water, which is surprising to a lot of people, but Mars has polar ice caps, and it has water underneath the surface of the planet. In fact, there are dried up riverbeds on the surface of Mars, and if you download Google Mars, you can check out some of the valleys and things like that, even some of the northern glaciers. And in the Martian summer, when it comes closest to the sun, a lot of the water evaporates from the north and the south poles of Mars and gets swept up into the atmosphere. It'll return later, but you can see how it would be very easy to seize hold of Mars at a particular moment when the water is evaporating and turn that water into a resource for people that land there. And almost all of the climates that are on Mars are something similar to what we can simulate here on Earth, like being underneath the ocean or being weightless or something like that. Some of the drawbacks are that there are big dust storms once a year, I think, or once in Mars's orbital cycle. There are these huge dust storms that cover up the entire planet, and this is the same logic of a dust storm that people think caused the die-out of the dinosaurs, because if there's not sunlight reaching the planet, for, I think it's up to like, what's the period, 2 weeks or something like that, then all plants on the planet die. Because they are not able to sustain photosynthesis. I think it's actually 2 months. And so the same sort of thing would happen on Mars. Because these dust storms are very routine, any attempt to establish plant life